made that decision completely yet. As long as we have time in class, we may still take it.
So how much time?
I'm trying. Jaden, believe me, I'm trying. I'd rather not take it today. I'd rather give you guys a chance to do as well as you possibly could. But that depends on how everybody acts. And if Dawson's actually writing stuff down and trying to do well. Right, Dawson? Dawson, I wasn't using you as a bad example. I was using you as a good example. So, what we're going to write down first, we talked about translations. So let's just write translations. Anything that we might want to write down about translations? What's another name for a translation? Slide. So translation is a slide. What are some key ideas that we might need to know about translations for this test? Okay, so there's like 3 different ways we could write them, right? And that's what I'm going to put up here, the 3 different ways that they could be written, or could be written. That's why I'm not an English teacher. 1, 2, 3. 3 different ways. Try to stay away from those stupid jumps. The first way, Harry said the first way is a vector. And I'm just going to give examples here so that we can use those. If I had a vector and it said -5, 2. Remember, it's got to be written with these vector symbols, comma in between. What does this tell us to do?
Left 5 up 2.
Left 5 up 2. This number tells you how to move left or right. This number tells you how to move up or down. The other, another one that we had was the rule. And I'm just going to write one out in this rule form. What's that rule tell us?
Move right 3, down 6.
Right 3. This tells us you're adding 3 to all the x's. So you're going to the right 3. This tells us you're subtracting 6 from all the y's. So it's telling you you're going down 6. Very good. And then the third way, it's like the 5th grade way, as if it was just written out that way, telling you exactly what to do. Right 3, down 6. There were some of those on the packet, right? Anything else that we should write about translations? Anything else anybody can think of that we need for translations? Not really.
It's basically the easiest one.
That's probably the easiest one, right? So you might write maybe on this one, what do you have to do a translation? Just what? Just count?
I thought it was going to say just.
So just count it, just slide it. The other thing that I might write up here before I erase this, because we talked about this, same time we talked about translations. What's a composition?
When you're doing more than one of the steps.
Okay, so 2 or more. What's the big word that we used at the very beginning? It covered this whole chapter. Transformations. Very good. 2 or more transformations. That's an A, not a D. Anything else about translations? what was the next transformation that we talked about? Reflections? Did we do reflections next? That's right. Everybody got all that before I erase it? So reflections. This is probably I don't want to say this is the hardest one because part of reflections real easy, but some of it is all new to you, so it's a little more difficult. So you might want to watch closely on this one. What were the easy ones? What would we reflect in or over that were easy? So x-axis, y-axis. If we were just reflecting in the x-axis or in the y-axis, what do you have to do if you're doing that? Just count. So you just count. If it's one above the x-axis, then when you reflect it, it goes one below. If it's two above, then you go two below. So just an example real quick, if I draw something over here, and we have this triangle, and this space right here, that's one. Well, then we count down one, and we put that point right there. If that was A, what's this new point become? A prime. And we do it for all the corners. So if it's just over the x-axis or just over the y-axis, you just got to graph it and count it. Now to the ones that were a little harder. So x equals some number. So if you're reflecting over x equals some number, the line x equals some number, x equals 10, x equals 4, x equals -3. First thing you need to know when you see that is that x equals a number is what kind of line? Don't tell me straight, please. Vertical. Everybody agree with that? Now see, I'm glad that you guys can remember it because anytime that I'm doing it, I have to draw it and think about it. So if it gives us something like, let's do an example here real quick. If it gives us something like x equals -4. What I have to do is I draw my little graph and I go, okay, x is -4, so I go out 1, 2, 3, 4. I figure out where x is -4. Well, if I drew in a horizontal line there, it'd just be the x-axis. So that's not going to be it. So I know when I get out to there, it's got to be this vertical line right there. And that's what we're reflecting across now. We're reflecting across that line, not the x-axis, not the y-axis. We're reflecting across that line. So if I had some shape that's right here, is it going to end up over here? No, that'd be if we reflected across the y-axis, right? Is it going to end up down here? No, that'd be going across the x-axis. It's going to end up somewhere over there. What do you do to figure out where it goes over there? Just count. So if that's one space over, then it's got to be one space over here. So you're just counting still. So what I'm going to write here, the two things you do, first thing you do, draw the line. So draw in that vertical line. The second thing you do, then you just count. Just count to do the reflecting. If you have questions as I'm going through and doing this, if Peyton doesn't understand what I meant by that, make sure you ask. Don't be afraid to ask. It's been a month or so since I called anybody an idiot. So give me a chance every now and then, Harry, all right? Jacob, when was the last time I called you an idiot?
Pretty sure it was, I think 4 days ago.
4 days? All right, so I was wrong. It's been less than a month, hasn't it? We probably better make sure, Jacob, because somebody's going to go home and say, Mr. Eversole was calling Jacob an idiot. He's been doing it all year long. Have I ever called you an idiot? No. Y equals some number. What's different about y equals some number?
Instead of vertical, it's horizontal.
It's a horizontal line. It's a horizontal line. What do you think you're going to do to to reflect over y equals some number? Same thing. First thing you're gonna do is what?
Draw a line.
Draw the line. Second thing you're gonna do? Just count. So if it was like this, let me get out of the way here. First, to graph it, if we had some line like y equals 2, we go to where y is 2, well, that'd be up 2. And we draw in a horizontal line. If we're going to reflect this shape over that line, we just count. How far is it from here to there? And then we come down here and we put that point there. How far is this point from here to there? We come down here, we put the point in, and whatever it might look like down there. And then mine doesn't look anything like it. So you just count, just like with the x-axis or the y-axis. Now, the most common mistake that most of you are going to make, if it's something like this, there's going to be a point. I probably shouldn't have drawn some crazy shape. I should have drawn some actual shape. If this is our line that we're reflecting across, and that's our triangle, what I'm going to see a lot of you do is you're going to count. And you're going to count to what? The x-axis instead of just counting to the line. Or you're going to count 2 to here, and then you're going to come to the x-axis, and you're going to go down 2 from there. You got to make sure that we're dealing with this line now, and it's like the x-axis isn't even there. Yep.
What's another question?
Sorry, what is it? Listen. Sorry.
Okay, well, is it pronounced axes or is it axis?
Either one.
Okay, because we've always pronounced it axis.
Axis. That's fine. I say axis.
Sounds good.
There's, I don't know. I'm not an English teacher, so I pronounce it. I know, what was one of the other words that we did earlier this year? The arithmetic mean, when we did the arithmetic mean, and you said that Mr. Harrison pronounced it arithmetic. So, whichever.
Okay.
As long as you know what it is, that's what matters. Other things with reflections, there was 2 other things.
Y equals X.
So if we're going across the line y equals x, the first thing that I want to do with y equals x, you might want to put this somewhere there. This is our axes. This is our x and our y axis. There, I said it that way. This is our x and our y axis. Y equals x, the line y equals x is the line that goes up from the left to the right through 0, 0, and it sort of splits our coordinate system into 2 parts. Splits it in half, going this direction.
Could it possibly be easier if the positive x it goes past the positive difference and negative x it goes with the negative?
Sort of. And that all the points that are on here are the points that match up. So if I pick this point right here, and I told you that the x was 2, what's the y got to be? Positive 2. The numbers are going to be the same. For every point that's on here, if I pick some point down here, and I told you that the y was negative 8, guess what the x has to be? Negative 8. Alright, so that's that line, y equals x. This is the one where we're going to, I know that some of you are going to mess up on. So if I had this, let's say that shape right there, I think this is sort of one of them that was on that packet.
Yeah.
And we reflect that across. I guarantee I'm going to get some people who's going to do this. Because that sort of looks right, doesn't it? Looks like how you would reflect it. But what did I reflect it across?
The y-axis.
I reflected it across the y-axis, so that would be wrong. All right? It's gonna be somewhere crazy, isn't it? And it's sort of hard to look at it. So what you have to do on this is you have to use the rule. If you don't use the rule, if you don't write down the original coordinates, use the rule, then graph the new coordinates, you probably are going to mess up.
You just switch to, y is, x, right?
I'm not sure, is that what it is? So the rule says what? XY goes to what? Just flips them? YX? Is that what it get? Is that how it is? Does everybody agree with that? So you've got to use that rule. What we'll do after this is I'll do a few of the problems off that packet that the sub gave you, and we'll maybe pick some of those so we can see it. All right, maybe pick that one that was like this. What's the other one? Y equals negative x. That one, when you draw it on the graph, it's the line, instead of going up from the left to the right, it's the line that splits it in half going down from the left to the right. So this line right here is y equals negative x. What was the rule on it?
I think there's, doesn't it flip it, like, big x
Yeah, so this doesn't make sense.
or switches, like you switch to negative y and negative x.
Negative y, negative x. Anybody agree with that? I hope that's right, because I don't have any clue what the rule is. You guys got it written down somewhere, right? Could you look it up?
Yeah.
Make sure?
It's right.
That's right? So that's the rule that we want to use when we're going across this line. Y equals negative x. I'm going to write three things here. First thing you're going to do, find coordinates of, what's the first shape called? Is that the image?
Yep.
Pre-image? Which one is it?
Pre-image.
Pre-image. So you find the coordinates of the pre-image. Find the coordinates of the pre-image. Second thing you're going to do, use the rule on those coordinates. Use the rule on the coordinates. Then the third thing you're going to do, graph the new points. Graph new points, or graph the image points. Got to do those for both of those. Same thing when we get to the rotations, and you got to use the rule. That's what you got to do. You got to find the coordinates of the first one, write them down. So if we're doing a problem, and it gives you a graph, and this graph looks like this, and it's got this rectangle here, and it just gives you that graph, first thing you want to do is find the coordinates of each of those. So if Molly comes down here on her test, and she puts down, okay, that coordinate is 2, 3, B is 6, 3, C is right there, and that is 6, 1, D is right here, and it's 2, 1. She writes down those coordinates for that original shape. I give her a point. If that's on your test, you write that down, you get a point. Because I know, hey, they're going in the right direction. All right? Next thing you're going to do is use the rule. So then we're going to find A prime, B prime, C prime, and D prime. We're going to use whichever rule it is. You write those down, you get another point. Then the third thing you're going to do, you're going to come over here and you're going to graph the new shape wherever it's at. You do that, you get another point. So the original points, new points, the graph. Give you 3 points.
Okay, so if it switches the x and y and
makes them negative? If they're already negative, wouldn't that make it positive?
Right, so, and that's another thing I need to say. When you guys are looking at this, and I got a son that's in 7th grade, and I yelled at him here a couple weeks ago, so now he'll never ask me for help on his homework again. And the reason I yelled at him is because he's looking at that sign right there, and he's doing some stuff like this, where they're having him switch the sign to do something with it. You guys got to quit thinking of that as a minus sign or a negative sign. What that means is the opposite. So when I write something like this, and I know your 1st grade teacher could never teach you this because you wouldn't have understood it. This is saying 5 and the opposite of 3. So you're combining together 5 and the opposite of 3. Well, the opposite of 3 you learned is a negative 3, right? So you're putting those together. So whenever you see that sign, I don't want you to quit thinking of it as a minus sign, because if you read this, of course, you're going to say 5 minus 3. Correct? But there's going to be times like this right here, where when you're reading this, instead of a negative, you want to say, okay, this is telling me to take the opposite of whatever y was. So if y was a negative 2, the opposite of a negative 2 is a positive 2. All right, so there's different times when this needs to be read different ways. Opposite, minus, negative. Anything else on reflections? Is that about it for reflections? Yep. Nothing else? Better hurry, Dalton's getting bored. What's after reflections? Rotations? You're getting bored because I'm explaining it too much and you know it all, right? What should we write down about rotations? All the rules. We had a little box, right? They might want to draw this box. I think, what, the degrees was first. Clockwise. Hopefully, and I'm going to put CCW for counterclockwise. Hopefully somebody's looking this up right now, because whatever you tell me, that's what I'm writing down. I have no clue if it's right or not.
90 degrees.
What angles are we going to turn things at?
90 degrees, 180, 270, 360.
90, 180, 270, 360. Now I'm going to do this very first thing. I'm not writing down anything for 360. What happens when you turn something 360? It ends up the exact same spot.
Can we just not put 360?
You don't have to write it down if you don't want, but
Do you want
so if you're not sure about 360, then you might want to write it down, right? But I know if I take some shape, if I take this shape, see my shape there? Watch, I'm going to turn it 360 degrees. See that? Amazing. That was
That's
magic.
very quick.
For 90, now Alyssa was getting ready to ask, do I want the A's and B's or the X's and Y's? Which ones are best for you guys? X's and Y's? Do we need to make 2 separate charts so that you have A's and B's and X's and Y's? Does it really matter?
No.
So which one? X's and Y's? So every single one of these is going to start off. That's our original point, X, Y. So I'm going to write that on every single one of them. X, Y, X, Y, X, Y, X, X, Y. Previous. X, Y, X, Y, X, Y. And they're all going to go to some new whatever it is. for 90 degrees clockwise, somebody help me out. What's the rule for 90 degrees clockwise?
B negative A.
B negative A. So how am I going to write that if I'm using X and
Y
Y?
negative X.
Y negative X. Everybody agree with that? And we should probably put rotations. We should put about, what's our center point going to be? The origin, or 0, 0. About 0, 0 on a graph. So to use these rules, you have to be on a graph. How about 90 degrees counterclockwise?
Negative YX.
Negative YX, everybody agree with that? About 180 degrees clockwise.
Negative X.
Negative X, negative Y. So what's that one do to it? Just does what? Change the sign, leaves them in the same order, just does the opposite of each number. How about 180 degrees counterclockwise? Same thing. Turning clockwise or counterclockwise 180 degrees puts you in the same spot.
Is that why you just kind of rotate through the
Yeah. So anytime you'll see something that's dealing with 180 degrees, it probably won't say whether to go clockwise or counterclockwise, because
If it is, it's just trying to trip you up.
right, it's just trying to make it harder than it had to be. 270. Everybody read that and know that that's a negative right there on that one. How come I even looked at that one? Those two are the same thing. If I turn 90 degrees this way, it's the same as turning 270 degrees the other way. So those two match up. What's going to be true about this one then? It's going to match up with that one. Y negative X.
If it's like, there's like 360, do you still have to do the like break the prime ones there too? Like, you know what I mean?
If it was on like the EOC test and they said something like turn it 360 and tell what A prime and B prime, then yeah, probably want to do that just to, because what they'd be doing if they were putting that on there is just trying to see if you knew that, hey, if I turn it 360, it ends up back in the same spot. They're just trying to see what knowledge you've had. All of this has to be on a what? Has to be on a graph. That's the only way that these rules work.
Are we gonna have the ones for
Yeah, I'm getting ready to do something about that.
Hang on.
You don't need a ruler.
The only ones that I don't know.
We're supposed to put it on the back of it?
Huh?
We're supposed to put it on the back of it?
Didn't have to.
I did.
You can put it on the back of it, or you could write it somewhere else. That was up to you. Now, if you don't have room on the back of it to write all, everything down that you want on there, then you probably want to put it on something else. So, if we're doing freehand with rotations, guarantee there is some of these on there. Freehand with rotations. Remember, what three things am I going to look at to grade you off of?
Is it the right direction, right shape, and out the right, or is it the right,
Direction,
degrees?
shape, or does it look the same? And then the amount of the turn, right?
If it looks that way.
Amount of the turn. So I'm going to look at those three things. Did you go the right direction? Did you go clockwise or counterclockwise? Does the shape look the same? Because when you're doing a rotation, what should be true about the image and the pre-image? They should be exactly the same. Did you turn it the right amount? So if I said turn it 180 degrees, if I'm here and I'm the image that I'm telling you to do it to, and I say turn it 180 degrees, and you turn me to here, did you turn it the right amount? No. So that's what I'm going to be looking at. So if we have something, do something like this. We're going to do a couple of them here. I'll erase it and try another one. If that's our center point, point C, and we have some triangle, that's our triangle. Remember, all you're going to do on this, you're going to have how much you're going to turn it, a direction you're going to turn it, and the center point. If this is going to be our center point, and let's say we want to turn it 60 degrees counterclockwise. All you're going to do, don't make this harder than it is. Come over here, how many degrees is that angle? 90, that's too much, right? So we want 60. Maybe something about like that. So that's the angle that we want, that angle right there. Something fairly close to that. You're going to take each of these points, P, Q, and R, and all we're going to do, and I have to do this, we're going counterclockwise, so I'm turning it this direction. It's like you're taking this shape, and it's hooked with the string to that point. So we're turning it 60 degrees counterclockwise. So if I could attach that triangle to that, all we're going to do is go counterclockwise about that angle right there that we just picked up. So from here, it would maybe go to about there. So when we're done with this, should our shape end up down here? Over here? Should end up right up in here somewhere, right? So that's what we're looking for. And all I'm going to do on this, 60 degrees, I'm just doing this, connecting P to C. It's going to come off at a 60-degree angle, somewhere about there. Figure out how far C is from P. P prime should be the same distance from that. So it's about that far, about that far. It's going to be easier on your paper because yours isn't going to be that long, right? It's just going to be something small, so you could do this. And just measure it that way. Or use your pencil and measure. It's about that far, measure it out. So we got that there. Do the same thing for Q. Hook Q to C, comes off 60 degrees. Ooh, that's way too much. Comes off 60 degrees, somewhere about there. About that far. So Q prime is going to go right there. I can hear Harry's mind turning, saying, you ain't going to be nowhere close ever, so. R, connect it, 60 degrees. I can figure out my lines here. Something about like that. About that far, about that far. R is going to be right there. R prime, sorry. Connect those. That's my new triangle. Did I turn it the right direction?
Yes.
Went that direction? Is that counterclockwise? Yeah. Does it look like I turned it about 60 degrees? Yeah, probably. Does it look the same? Well, maybe not, but. Alright, so.
You got close.
If you did this, I'd probably give you all 3 points. If I do it, yeah, I probably should have done a little better. Alright? But that's all you're going to have to do. Just think about it. If it helps you, think about, okay, I got a string right there. If I could hook to that. Jason comes over here and he grabs a piece of scrap paper. And I see him doing this. And he rips out this little triangle here, rips out a corner, and he goes, 60 degrees. I don't care, go ahead. Right? Do whatever you need to do to help you figure it out. Now the other one, we didn't do a whole lot of this, but I want to show you this. Because I know that I could throw something like this on there. If we have this triangle, triangle AB, let's get rid of that. We have triangle ABC. If we want A to be our center point, all right, and we're going to rotate it about A, where's A prime going to end up when we're done?
Same position.
Same position. So all we're going to do all that's going to happen is this triangle is going to rotate however many degrees, but that A is going to stay the same. So if I wanted to rotate it 60 degrees, all that's going to happen is B is going to come down here, hit it. It's going to come off at a 60-degree angle, so maybe B is going to end up somewhere, or B prime is going to end up somewhere about here. C is going to come over and hit it, 60-degree angle, somewhere about in there. So that's going to be C prime. Our new triangle is going to be something like that, where A stays in the same spot. So all that did was it changed our center point. Our center point this time actually is a point that's on the triangle. Don't make that harder than it is. Anything else about rotations that we need to write up here?
Are there rules?
Is that it? Nothing else about rotations? What's the last one? Dilations.
If you want to do
Congruency, we'll talk about that here in a second. So let's talk about it right now. A congruency transformation. Is a dilation a congruency transformation?
Yeah.
No, which transformations are congruency transformations? Rotations, translations, reflections. Because when you do those, what shape do you end up with as your image? The exact same thing. Dilation, similar transformation, because you end up with a shape that's similar to the original. So if we're on a graph, what do you do with all the coordinates if you're on a graph? Multiply all x's and y's by what? Which is called the what? The k, the scale factor. So multiply everything by the scale factor. Multiply everything by the scale factor. So if I do this example, I got those 3 points and our scale factor is 1/3. I wanted to do a hard one just to, because I know how much somebody loves fractions. What are you going to do with that k? Just times it. Get your calculator out and take each number times that. All right? So somebody tell me, what's A prime going to be? What's 2 times 1/3? 2/3. What's 1 times 1/3? 1/3. B prime. What's -3 times 1/3? -1. What's 4 times 1/3? 4/3. 1 and 1/3. Either one of those would be fine. What's C prime? 1 and 2/3 or 5/3? 2. Now we have all those new points. Now Alyssa, if Alyssa wants, if you have to graph this and she wants to change all of those into decimals so that she can graph them, go right ahead. All right? Or use your calculator from the beginning and just say 2 times 1 divided by 3. Don't make the fractions harder than they are. All right? Most of your scale factors are going to be things out in the real world where you're making something smaller. When you take a picture, guess what you do to the person you're taking a picture of? You're making them smaller. All right? Your pre-image is always going to be bigger than your image when you're taking a picture. Shouldn't say always, maybe not. So all you do, you take each one of these numbers, multiply it by whatever the scale factor is. If it's 2, 2 times 2 is 4. 2 times 1 is 2. Then you graph those new points. Same idea on this one as on the rotations and the reflections that we did. Same idea on this one. if they just give you a shape, and that's our shape, you find the original points first, I give you a point. Then you find the new points, I give you a point. Then you graph the new shape, whatever it is, I give you a point. That's if you're on a graph. That's all you do if you're on a graph. What if I'm not on a graph? You're not on a graph?
Isn't that when you have to do like a live field of
Put it on the graph.
one point?
Put it on a graph? You could. Now, what if they just give you, so if you're not on a graph, but they just give you the size. So let's do this. I have a picture of my person here. And I know that person is 6 feet tall. And I take a picture of them, and I want to know, if I take a picture with my camera, I know that my camera is a 35 millimeters. Anybody have any idea what that means when it's called a 35 millimeter camera?
It's how wide the picture is and stuff like that.
That's how wide the picture is. So they're saying, hey, you're going to change this guy down to
This guy.
35 millimeters. All right, so 3.5 centimeters. That's what it's saying. That's like a scale factor, like how much you're reducing it. So let's say we knew that my camera had a scale factor or a reduction rate of 110. 110. What do we do with that 110?
Multiply 6 by 1, divide by 10.
Multiply it. You're still going to do the same thing. You're going to multiply this times that, all right? And here he said to do that, you multiply the 6 times the top number, divide by 10. So what is 6 times 1? 6 divided by 10? 0.6. So the new image that we have is going to be how tall? 0.6. That's all you do. If I give you a picture frame, and I tell you that picture frame is 5 by 7, and we got the picture of me in there, and we want to enlarge it because we want my picture to be as big as possible. Shh, keep walking. We want that picture of me to be as big as possible, so we want a scale factor of 12 because we want to make it huge. What do I do with that 12 in relationship to this 5 and 7? Just multiply it. What's 12 times 5? Somebody grab your calculator. We're wasting time. 60, thank you. What's 12 times 7? 84. So how big is our new picture going to be? 60 by 84. With dilations, all you do is you take your scale factor and you multiply it times everything. Now, some things you got to be careful on. I know there's one of these on the test, so you might want to listen carefully. I have a picture. I have this poster. And the poster's too big to fit on my wall, so I want to reduce it down. And I want to go 75%. If I'm multiplying by 75%, am I reducing or enlarging it?
Reducing.
Which one is it?
Reducing.
Okay, so
It's reducing because it's 0.75.
If this is my scale factor, 75%, am I enlarging the picture or reducing it?
Reducing. It says it's too big to fit on your wall.
I'm reducing it because what do you got to do to this 75% before you can do any math? Change it to a decimal. What is it as a decimal? 0.75. So it's a reduction. You've got to remember that. Change it to a decimal first.
Now, if it was over 100, that's when.
So that's my next thing I'm getting ready to say. So if I had something and my scale factor was 125%, is that a reduction or an enlargement? That's an enlargement because what is that as a decimal? 1.25. That's bigger than 1, so it's an enlargement.
Does that mean you're increasing the size by 25%?
Sort of. We see we don't want to say that because if I take take this square right here, if this square is 2 by 2, and I say my scale factor is 12, then that means the new square is going to be 24 by 24, right? Does that mean that that the area of this square is 24 times the area of that square? No, it means that the length of this side, or not 24 times, 12 times. The length of this side is 12 times as long as the length of that side. So if you're dealing with the perimeter, then the scale factor can go with perimeter. But because the perimeter of this one would be 8, the perimeter of this one, 24 plus 24 plus 24 is what, 96? Guess what 12 times 8 is? 96. So the perimeter is 12 times this perimeter, but the area of this one is not 12 times the area of that one. Does that make sense?
Is the area like a whole thing?
Yeah, area's sort of different. What else did we do with dilations? All the freehand stuff, right? You guys thought maybe we weren't going to do those. The freehand dilations. A couple of things, just real quick. Yeah, we'll do this. So if our center point is C and this is our triangle, looks something like that. If our scale factor, I don't care, somebody give me a scale factor. 2. So if we're going to do 2, we draw these rays. If this is A prime is going to be on that ray somewhere. Well, how do we know where it's going to be? Well, it's going to be twice as far from C as A was. So we measure this, and we go times it by 2. So we got 1, 2, somewhere about there. A prime is going to end up somewhere out in there. That's an A prime. And then we do the same thing with the other points. All right. I'm not going to go through all that. You do the same thing with the other points. You end up with maybe B prime, C prime, so on, and the shape gets what? Bigger.
But when you're reducing it, is that when you go 8 to C?
So if you're right. Well, not necessarily. You still go here,
But you go out further.
but if our scale factor was 1/2, we don't want this whole distance in. We want what? Half of it. So A prime would come, stupid pen. A prime would be halfway in between there. So, and that's one of the things I wanted to say. So if we have this, don't make fractions harder than they are. If I have 1/4, if that's our scale factor, this is C, that's A, then that means C is going to be 1/4 of the, or I'm sorry, A prime is going to be 1/4 of this distance. Well, do something like this. Don't make it hard.
Right.
Just cut it into 4ths. Those don't all look quite the same, but close enough, right? Am I going to take off points if that's what you come up with? No. So if A's here, A prime is going to be 1/4 of that distance. So we just go out 1. That's where A prime is going to be. We do it for this point. We split that into 4ths. 1, 2, 3, 4 parts. B prime is going to be right there. We do this distance. We split it into 4ths. Horrible at this. 1, 2, 3, 4. We put it right here. Our new triangle. A lot smaller. It's going to be somewhere like right in there. If you're dilating it, instead of some point outside it, if you're dilating it and the point's in the center, if you have a scale factor like 1/4, is the shape getting bigger or smaller? Smaller. So what you want to do, you see that distance right there, from there to there? We want 1/4 of that distance. Then we want 1/4 of this distance. Then we want 1/4 of this distance. So our new triangle, ignore that. Our new triangle is going to look something like that. It's going to like squeeze closer to the center point. All right? What if I had a scale factor that was 4 and our center point was here? Then it's going to, and it should be evenly, it's going to spread out away from that center point. So this distance from here to there distance from here to there would have to be 4 times that much. Just get 4 times bigger. Now, am I probably going to put one like this on there that's 4 times bigger? Probably not, because what's going to happen on your paper? You're going to be off the sides, and I wouldn't be able to grade it anyway. That's what I'm getting ready to talk about right now. If we have a negative scale factor, let's do this. If I put my shape right here, this is our center point. This is our original shape. This is our pre-image. What we start with. If your shape ended up out here somewhere, what kind of scale factor would you have? K would have to be what? Greater than 1. So give me a number. 2. K was 2. That's where it ended up. What's happening to the shape? It's getting bigger. What if your shape ended up here? It's getting smaller. Scale factor could be something like 0.2. Now, let's jump over here. What if you end up right there? You're still getting what? Smaller. On this, when you're doing scale factor, your center point, the image, or I'm sorry, the pre-image is going to make, or that I was right the first time, the image is going to get closer. So here it gets closer to the center. If it gets bigger, it gets farther from the center. This stuff stays the same, bigger and smaller and closer. So this one's still going to be closer to the center. But what else did it do?
Change sides.
It flipped over the center point. What would cause us to flip over the center point? A negative. So like negative 1/3. All right? What's going to happen here? Got bigger. Got farther away from the center again, because when it gets bigger, that's what happens, right? It flips. What kind of scale factor would give me something way over here? -4.
So when it's smaller, when it's still fractions?
When it gets smaller, it's going to be, now I don't want to say it's fractions or decimals, because if I gave you this scale factor, is that going to make the shape bigger or smaller? Bigger, because it's larger than 1, but it's a fraction.
So if it's less than 0.0.
If it's anything from -1 to 1, it's getting smaller.
If it's anything else.
If it's anything out past -1 or out past +1, it's getting bigger. And if it happens to be 1 or -1, what's it doing? Is it getting bigger or smaller? Staying the same. 1 is going to just be like a 360 turn. The only other thing I want to say, vectors. Vectors, and actually I want to do this. We have this vector. Don't make vectors harder than they are. We haven't done them since like the first section, but they're not that difficult. And I know there's a problem on the test that says this. First of all, somebody name that vector for me. AB. Do I just write it AB like that? Is it ray AB? Use the vector symbol, right? It's like half of a ray. So vector AB.
It's like a check mark.
All right. Check mark laying down. Now, they seem like that surprised them that was smart, Peyton, that you said that. That should make you think. When I want to write its components, how do I figure out what the components for A to B is? You just count. All right? What comes first? The X. How much we move from here to there? How much would I move to go from here to there? 6. Is it positive or negative? Positive. So 6 goes in here. Ignore that. And then what's the second part? Up 4. So what goes here? Positive 4. This is how you name the vector. This is the component of the vector. So if I had a vector that did this, Q R. Tell me how to name that vector. QR. Now give me the components.
-3.
So I went from here, over to there. So that's positive 3, right? Down 6, so -6. Please make sure you don't get those backwards. Don't think rise over run, because it's different for vectors, right? So it's how much you move on your X, how much you move on your Y. Run over rise, right, if you want to think of it that way. Anything else you think we ought to put on there? Think that's enough?
Yeah, I feel pretty.
Don't get all that, or did I lose him about halfway through? No? No, you didn't get it all, or no, I didn't lose you? Alright, what I want you to do, get out the packet. What do we got, about 18 minutes? Get out the packet. I'm going to try to go over some problems off the packet. So look through it, figure out some that you might want. Figure out some that you might want to see. I'll give you a minute to look through it, and we'll try to do them up here. Yeah, we're going to talk about it.
Make sure you copy down the answers of your class.
She just spoke.
That makes my throat drier.
Oh, yeah. Sounds like
I started to drink that. We'll get some of this All right, problems you want to see worked off there? Yes, Mackenzie. Number 5. Number 5 on page 9. Find it real quick. Five on page 9. Might want to be writing this down if you didn't get all this done. Might be helpful. So we got this shape. Let's see. Somebody help me out. Tell me what the coordinates of A are, so I don't have to try to figure it out. -4, -2, that's A. What's D? We still got time to start this test if we need to. That's D. What's the rest of them? like that, is that right? So that's our original shape. It says the image is rotated 90 degrees clockwise about the origin, then reflected across the x-axis, then translated 3 units right, 5 units up. So they're actually doing 3 things to it. So the first thing, 90 degrees clockwise. Did we have a rule for 90 degrees clockwise? What was it? Y negative x? Is that what somebody said? So we're going to take each one of those points that you just told me there. A was -4, -2, is that right? B was -1, -2. C was -1, -1. D was -4, -1. So we're going to take each one of those points. What are we going to do to it? Flip them around and then switch the sign of the second one. So, because I don't have room over there, A prime, we're going to switch it around, so that's going to make it -2, -4. I'm just switching it for now because I'm going to confuse myself if I try to do 2 things at once. -2, -1, it's number 5 on the page 9. Letter C is -1, -1. Harry, did you see me switch that one around? D is -1, -4. Did you see me switch it? Now, I'm not to that point yet. Come on, Harry, I was trying to be funny. So I switched them around. Now, which one am I going to change the sign of? The second one. So you just go down through here and you change the sign or do the opposite of the second one. Well, in this case, that just ends up making all of them positive. Now I'm going to regraph that over here. So -2, 4. 1, 2, 3, 4. -2, 1. -1, 1. And -1, 4. So now our shape looks something like that. -2, 4. That was A. That's A prime. -2, 1. That's B prime. -1, 1. That's C prime. That's D prime. What's the next thing they tell us to do? Reflect it over the x-axis. What are we going to do to reflect this over the x-axis?
Count.
Just count. How far is B above the x-axis?
1.
So it's going to end up right there. How far is C above?
It's the section.
It's the same spot that C was before on the A is how far up? 4. So it's going to be down 1, 2, 3, 4. And the other one's going to be down 4. So that's our third shape. Then what's the next thing they tell us to do?
Right 3, 5 up.
So I want to take each one of these points and move it right 3. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. So that's where our shape ends up at. Now, after all that, did they care about the graph? Did they say graph all that? No, what'd they say? Give the new coordinates. So we need the coordinates for that shape right there. What's the coordinates of that point?
2, 4. Wait, no, that one. 1, 1.
1, 1. What's the coordinates for that point?
2, 1.
2, 1. What's the coordinates for that point?
1, 4.
1, 4. What's the coordinates? Oops. What's the coordinates for that point? 2, 4. Those are the answers that need to be over there on the blank. None of this mattered to that problem. It's just how we got there. That's the answer that they wanted. Next question. Pick one not so long. Number 8. Which page? Page 10. Number 8 on page 10 says, use scalar multiplication to find the vertices. Now, where most of you are probably having a problem with this one. Scalar multiplication. Probably don't know what that is. All it is, that's your scale factor. It's just another way to say scale factor. So guess what you're going to do with your scale factor of 1/3 right there. Multiply it times everything. So let's, I don't even need the graph here. We want to find Q prime. What was the original Q?
-3/4.
And what's our scale factor? 1/3. So all we're going to do is take out 1/3 times each of those numbers. What's 1/3 times -3? -1. What's 1/3 times 4? 1 1/3. Next one, R. So R prime. What's -2 times 1/3? Negative. What's 2 times 1/3? 2/3. What's -1 times 1/3? -1/3. Next one is T prime. We look at T, what's 3 times 1/3? 1. What's 1 times 1/3? And then we want W prime. What's 3 times 1/3? What's 5 times 1/3? Five thirds, that would work. Or since we did this one this way, I'm going to put 1 2/3. Now, if you do all those, if you give me the decimal answer, would I probably throw a big fit? Probably not.
What it, oh, never mind, that's a 2. I thought it was a 3. I was like, what it, 1/3 out of 3, 3, 2.
3 over 3 would be.
Okay.
Other questions? Better ask now. Huh? 3 on page 8. 3 on page 8. Problem 3 on page 8 says, the original coordinates of the figure are that after a size transformation, the new coordinates are those new ones. What is the factor of the size transformation? In other words, they're asking you for the scale factor, so we're trying to find K. Remember, with scale factor, it's always, stupid thing,
It looks like a heart.
image, and we probably should have wrote this down. You might want to write this down on your notes. What's scale factor? What's K? Because we forgot it. Image over what? Pre-image. You might want to write that down somewhere. Scale factor, K, is always image over pre-image. You might want to write that on your notes. Pick me one of the numbers from the image. Is the image the original or the new one? The new one, right? So pick me one number from the new one.
1 to 10. 5.
10. 5? 5, is that what we want to go with?
Yes.
So that's going to go on top there. What's it match up to in the old one?
1.
1. Reduce this down. What's 5 divided by 1?
5.
Guess what your scale factor is? 5.
It looks like a little heartbeat monitor.
It's that easy. What if I gave you this? And if I told you this was the original, this is the new shape. And I told you that side right there was 40. What's the scale factor? So it'd be 40 over 10, which reduces to 4. It's always image over pre-image. I think you guys were the ones, weren't you the ones that said, what did we use? Was it this class? Instead of image and pre-image, because everybody was having trouble remembering those. Maybe new over old. Whatever you use to remember, it's always going to be that way.
What page was that one?
What was that, page 8? Number 3 on page 8. That packet, I'm going to count, it'll be turned in on Tuesday when you take your test. It'll be counted as extra credit, so do as much of it as you can, and the more you do, the more extra credit you get.
Wait, this packet that we just.
The one that we were just going over. This one that I'm handing out now will be collected on Monday. This is your assignment. That's right. Tuesday. This will help you study for the test.
Yeah, I know. When you're working out for his birthday.
Hey, Molly. I'm sorry.
Then give one to. Jason, will you pass that back? So on the review packet, do at least 40 problems. The other packet, again, I'm going to count as extra credit. 1 page of notes for the test. As you're doing problems, maybe you want to write something else down on that stuff that you wrote down. Make sure you got that come Tuesday. All right? If you forget it, I'm going to say, that's all right, Jason. Don't worry about it. You can take the test next time. Right? That sounds just like me, doesn't it? Absolutely not.